Python. Creating better rooms in text RPG with unique elements that change based on player actions. I am very new to coding and I'm probably biting off more than I can chew here. So please try to excuse my ignorance. I am attempting to make a text-based RPG in Python. My goal is to make something that isn't just a simple choose-your-own-adventure story and actually has combat, set and random encounters, with a leveling system, shops, inns, and quests. It probably looks like a disgusting mess to anyone more experienced, but I do actually have everything working and the game is currently in a playable state. Although the ending is still in progress. Right now I am building all the rooms as functions like this. Def generic underscore room. Global enemy underscore spawn underscore set. Global spawn underscore rate. Path equals. Print. Line 101. While path equals. Print. Make selection. Quote. SELC equals. Input. Upper. If SELC equals north. Print. Line 102. Enemy underscore spawn underscore set equals enemy underscore spawn. Spawn underscore rate equals 3. Encounter underscore initiatin. Path equals. Quote. Print. FN, path. Generic underscore room underscore other 2. LFSELC equals, explore. Print. Line 103. LFSELC equals, heal, and P1. Pots greater than 0. LFSELC equals, heal, and P1. Pots equals 0. Print. FP1.name, is out of potions and unable to heal at this time. LFSELC equals, stats. Stat underscore check. LFSELC equals, help. World underscore menu. Else. Print. Please select a valid command or type help. N. Now most of the rooms have elements that are unique from each other. Some are intended to change their intro text when certain conditions are met. I.e. a key item found. Boss defeated. ECT. Some have NPCs with multiple lines of dialogue that are affected by inventory. Right now I have these conditions implemented as additional if statements within the specific rooms function like this. LFSELC equals, east, and lantern equals 0. Print. Line 909. Elif. SELC equals, east, and bear equals 1. And lantern equals 1. Print. Line 914. Boss underscore initiatin 0. Bear equals 0. Axe plus equals 1. Print. Line 912b. Path equals, den 1 inch. Print. FN, path. Dungeon underscore cave 1. Elif. SELC equals, east, and bear equals 0. And lantern equals 1. Print. Line 915. Path equals, den 1 inch. Print. FN, path. Dungeon underscore cave 1. Even though the game works. I was wondering if there would be a better way to do all this using classes, dictionaries? I think I've found some good resources on how to build rooms like this. But in all of them the only thing that changes is the items located in these rooms. Would it be possible to alter a room made with classes, dictionaries, based on the events, like the ones I detailed above, that occur within? Additionally, I have seen a number of text game tutorials that essentially build their worlds in the same way, using functions to define each room. Other than the code starting to look a little bloated as the game gets larger. Is there a reason not to do this when it seems like the simplest, most straightforward method? Thanks in advance for any assistance or suggestions. I think you have found one of the reasons for the existence of object-oriented programming. It's a way to structure code that makes the rules of the domain problem explicit. That means that the code is more readable. Which means that in 6 months, After you took a break from your code and want to resume development, you won't hate yourself so much. Classes are ways of bundling behavior of generic things of the problem domain, in this case, the way you want the game to be. So you probably need a room class, which specifies the generic behavior and properties of a room. Writing classes, you can create objects with variations of those attributes. Your global variables are probably attributes of some class. For example, pot sounds like an attribute of the player, because common sense guides us to think that it's something that is had by a player. That's how you build up OOP code. You think about the relationship of things and you model classes that reflect that understanding. To give examples, the way I think about that in OOP is this in pseudocode. Class player. Def ___ init ___ self inventory equals self HP equals 100 self FP equals 50 self moves _history equals self location equals none self.is _turn equals true def locate self room self location equals room def attack self enemy attack _type if self FP greater than attack _type cost enemy HP equals enemy HP attack _type value. This class can be read as a player is an object with an inventory HP FP a moves history etc. and can be located and can attack. And let's say you have a game or a match that runs and spawns a player in a room with an item inventory and such. Class game. Def _init self player equals player self player inventory equals inventory self player locate room. This says a game is made of a player with an inventory and located in a room, where player, inventory and room are classes. When instantiated as player, what is executed is their __init method. You can read more about that method in the Python docs. For example, we want to specify that the initial inventory is a simple wooden sword. Then I would make the init method of inventory to be like this. Class inventory. Def _init self weapons equals simple wooden sword self clothing equals self.key items equals self pots equals 2 def discard weapon self item if item in self weapons remove item. You can alter a class attributes by using its methods. You have to build useful methods that capture the way you think a room can change and the way a player and enemy can interact with a room. For example, as to your last question, how you choose to structure your code is subjective and up to you. But there is no need to reinvent the wheel. There are industry standards that guide how to structure industry-grade code, as certain practices are known to lead to more controllable, predictable outcomes, for example, modular code, explicit interfaces between modules, etc. But there is also no silver bullet. When you show your code to another person for the first time, if you show them a single function that is 2,000 lines of code, their reaction is pretty predictable. They will hate you. It's going to be hard for that person to read the code as text and untangle the problem domain logic, what you want your game to be like, from the solution domain, what you were able to implement with your knowledge. We want to build modular code. We probably want the code to be useful to explain to ourselves and to others how we think the problem through. OOP is kinda really good at that, and arrives naturally whenever the logic of a problem becomes complicated. Hope this helps.